let's look at the graphs of a quadratic function, and we'll use the software GeoGebra to generate these graphs in this video. Now, the simplest quadratic function that I'm thinking of right now is this: y equal x squared. Okay, there you go. That's y equal x squared. Let me make our curve a bit thicker. You can see it more easily. Now, let's zoom in a bit. Alright, good. So, you can see here that when we have x being 1, x squared is 1. So, it's 1 squared, which is equal to 1. When you have x equal 2, then you have x squared, which is 2 squared is 4. So 2 corresponds with 4 here. Let's go up a bit further. When we have x is equal to 3 and 3 is here, we have 3 squared, which is 9, and this is 9. Alright, if we look at -1, when x is -1, y is -1 squared, which is +1, which is right at this point. So we have 1 squared giving you 1, and 1 is here. This is 2, 2 squared is 4, which is at this point, and this is 4 right here. What, -2 squared? Let's see now, -2 squared also equal to 4, because -2 times -2 is +4, right? And at -3, this is -3. Let's go up and see where this vertical line goes. It reaches the graph here, and when you project horizontally to the x-axis, you reach 9, because -3 squared means -3 times -3, which is +9, and so on and so forth. Alright, so we have the graph of y equal x squared. I'm going to just erase these writings and points. Now here we have y equal x squared. We have a minimum point, meaning if you should climb down into the valley of the graph, you will go lower and lower, because you are at, say, -3. You want to reach -2, -1, 0, 1, 2, 3. You're heading to the right, but you have to go downhill until you reach right here to the bottom of the valley before you start climbing uphill again. Now the lowest point that you reach is called the minimum point. Now the line that passes through the minimum point here is the y-axis, and this line is called the axis of symmetry. Alright, so that line is a vertical line, and it's called the axis of symmetry, because if you should fold the curve onto itself, you would have the left and right hand side match each other if you should fold the curve around this line onto itself. Alright, so that's the axis of symmetry. Alright, now let us look further at this curve. When we have y equal x squared, oh, beg your pardon. Alright, when we have y equals x squared here, right, we have a quadratic function in the form y equals ax squared plus bx plus c, where in our case b is equal to 0, c is equal to 0, a is equal to 1, because y equals x squared is the same as y equal 1 times x squared. Alright? Suppose we consider y a curve y equals x squared plus 1. What would happen? Y equals x squared plus 1. Let's draw it separately. Y equals x to the power of 2 plus 1. Alright, we have another curve. Let's make the line thicker and let's change the color of our curve to red. Alright, now the red line is y equals x squared plus 1. In fact, I want to see the equation. I want to see the equation of the curve near to it. Alright, it says g of x is equal to x squared plus 1. And for this, I also want to see the y equals x squared. Right, so the function here is saying f of x is equal to x squared, and it's in black. Here g of x is equal to x squared plus 1 is in red. And as you can see, when you plot y is equal to x squared plus 1, it's really like y equals x squared, but it adds 1 to each point. So every point on the curve moves up one place. This is at 0, this is at 1. This moves up by one place. You have a translation vertically upwards. 1. This was 1. What happens here is at 1. Now it happens at 2. Alright? So you can see that. So every point is moved up by 1 unit. So you have a translation upwards of 1 unit. Alright? So that's what happens with y equals x squared plus 1. It's x squared, and then you add 1 to it. Now I would expect that if I should have y equals x squared minus 1, it should look like y equals x squared, but should move downwards 1 unit. Right? If y equals x squared plus 1 moves y equals x squared up by 1 unit, then y equals x squared minus 1 should move y equals x squared down by 1 unit. So let's see. Let me erase these things first. I'm going to plot. Let us plot y is equal to x squared, x to the power of 2 minus 1. Alright. Let's just make this line thicker. And let's change the color to blue. Right? And I want to see the label of it. Alright, so what they say here is that in blue, h of x, in the software it doesn't say y, it gives me g of x, h of x, f of x, and so on and so forth. So the one in blue says h of x is x squared minus 1, And you can see here that we have x squared, y equal x squared, but y is equal to x squared minus 1. It moves y equal x squared down 1 unit. So it moves every point downwards. This was 0, it goes to -1. What happened here at 1, this point, it moves down by 1 and it goes to 0, right? So every point on y equals x squared is moved downwards by 1 unit. All right, so you can see that. So again, we have the original function that we had was y equal x squared. Y equal x squared plus 1 moves each point of y equal x squared up 1 unit. It adds 1 to each point. Y is equal to x squared minus 1 actually moves y equal x squared down 1 unit. Alright, so we'll continue looking at this topic in a different video.